Today we're continuing on with our quadratic unit. We're going to be doing quadratics all this week, and then next week we'll review the first couple of days, and then we will take our test on Thursday, I think. And Friday of next week is a holiday because it's Good Easter, or Good Friday of Easter weekend, and then the following week is when we'll have, no, that was the test, that's right. So anyway, you'll have a 3-day weekend right after we take the test on this unit next week. But this week we come to school Monday through Friday. So anyway, here's what we're doing today. I wanted to remind you when we solved equations. So when we had an equation that had an equal sign in it, and we wanted to solve for x, we wanted to know what number next x needed to be. If I subtract from 3 and then multiply that answer by 5 and then add 2 to it, it's going to equal negative 3. Well, of course, we did that by drawing a line through the equal sign, and the goal is to get x on this side by itself by undoing operations in the inverse operations in the reverse order. We did reverse PEMDAS. So normally you would do what's in parentheses, so this is the last thing I'm going to do. But we're going to kind of simplify first and stuff, so we'll talk about that. But anyway, this is what we did. I always told you to simplify before you get started. So is there anything to simplify on the right side? No. Anything to simplify on the left side? Yes, we have parentheses. How do we get rid of parentheses when we cannot do what's inside? We distribute. Since there's not a little exponent out here to do exponents first, we're going to distribute first. So 5 times x, we're just simplifying this left-hand side before we start solving for x. So this becomes 5x, and then of course 5 times negative 3 is negative 15. And then that's the end of the distribution. Then I still have the plus 2 sitting out here, and that equals negative 33. Simplifying further with any like terms, yes, these two can go together. They're like terms, so this becomes 5x. Negative 15 plus 2, bad guys are going to win, so this is negative 13. And this equals negative 33. We finally got this side simplified because I cannot add these together, and there's nothing over here to simplify. So now I'm ready to get x by itself. I check, is x only on this side, or the x is over here too? Nope, just x is on this side, so I don't have to move the x's to one side. Now this is multiplication and this is subtraction. Which one do we undo first? We do reverse PEMDAS. Normally we would multiply in PEMDAS before we subtract. So when we're solving, we go in the opposite operation. We undo this one before we undo that one. So we would add 13 first because we're doing the opposite operation. Instead of subtracting 13, we add 13. If you do it to one side, you do it to the other side. And we rewrite the whole thing. The 13s are gone, they canceled out. 5x comes down, equal sign comes down, and of course negative 33 plus 13 is a negative 20. And then how do we undo multiplication? We divide. So we divide this side by 5. Whatever you do to one side, you do to the other side. The 5's cancel out, which is why we did it, and x is now equal to whatever this number is, which becomes a negative 4. So x was negative 4. Now I know we learned to solve by hand, and we're going to practice this a lot at the end of the year after the STAR test. But of course on the STAR test you can still do it by hand. But even if you do it by hand, I want you to check it with the Inspire calculator. We can go to nsolve in the Inspire calculator, type in this whole equation just as it is, put a comma at the end, and write an x after it. So we're going to type in the whole equation, put comma x, and then close the big parentheses. And it will tell you x equals negative 4. Okay, so I just want to remind you of that, because now what we're going to do, notice in this equation though, x was to what power? It was the first power. So today what we're going to do is solve an equation, but it's got x squareds in it. And of course we know when we have, now these all made linear because there's x to the first power. So if you were to graph this thing, x equals negative 4, it makes a straight line. If you were to graph the original equation, it would be a straight line. So this one, if you were to graph it, it makes a parabola. All right, so now let's go ahead and do the same thing. We're going to get x on one side by itself. We're trying to solve for x. What number does x need to be that if I square it, take that answer times 2, and then take that answer, add 5 to it, equals 77. So again, we simplified. Anything to simplify on the right? No, can't do anything with 77. Can I add 5 and the x squared term together? No, so there's nothing to simplify. So the goal then is to get the x on one side by itself. Again, reverse PEMDAS. PEMDAS says do exponents first, then do multiplication, and then add the 5. So which one do we undo first? Yes, we undo the 5 first. That means I'm going to undo the x squared, the very last thing, since it was the first thing I would do if I was following PEMDAS. So let's undo adding 5 by subtracting 5. I do it to one side, do it to the other side. So this is all just like we've been doing all along, equals 72, equals, and then of course these cancel out, bring down the 2x squared. How do you undo multiplying by 2? You divide by 2. If you do it to one side, do it to the other side. So now this gives me x squared is equal to 36. Now we haven't done any of these yet, but we will do them a little bit now, but we're going to practice this a lot at the end of the year after the STAR test. So we did everything up to this point. And when we were doing our radical units, when we had square roots and stuff, I kept telling y'all the opposite of squaring something is the square root, because we would say, well, 3 squared equals 9. And then if they were to ask you to take the square root of 9, they want to know what times what, the same number times itself equals 9. And of course that was 3. So taking the squaring something, and then taking the square root of it puts me back right where I started with the 3. So squaring and square roots undo each other. So the whole reason for that was if I have something being squared and I want to undo it, I need to take the square root of it. These two things undo each other. Because inside here I have x times x. What times what will give me x squared? Because that's what the square root is telling me to do. It's just a single x. So if I do the square root to one side, I must do it to the other side. Now, the tricky thing to remember when you're solving and you put the square root symbols around them is that this needs to have two different answers. It is both plus and minus 6. We know the square root of 36 is 6 because 6 times 6 equals 36. But remember this problem up here, right before we did the square root symbol. X squared equals 36. If x is a positive 6, 6 times 6 equals 36. What if x is a negative 6? Negative 6 times negative 6 also equals 36, because that's what squaring is having you do, is multiply it times itself. So when you're solving an equation, you put the square root around this number, you want both the positive and negative answer. So you need to be sure and say there's two answers, x equals positive 6 and x equals negative 6. The short way to write that is x equals plus or minus 6. So this is a plus or minus sign. All right, so that's what we're going to be doing now, is practicing when we have an x squared. And of course, this makes a parabola. There's two answers, because if you were to go graph this thing, it crosses the x-axis how many places? 2. Remember, x-intercepts are the same thing as solutions. So when we're solving these equations, we're looking for where it's crossing the x-axis. We could have also done that with graphing these, but we have nsolve, and so we were just putting in an nsolve and just having it do it that way. Now, you may say, well, how come I can't put this in nsolve? Because it's a squared, and nsolve has its limitations. Nsolve won't solve inequality symbols, and it'll only do equations when it's a single equation with just a single variable. This is a single equation with a single variable, but it's being squared, and there's going to be two answers. If you put this in nsolve, it's only going to tell you the positive 6. It won't tell you the negative 6. So that's why it's important that you know that nsolve has its limitations. So these are some that you're going to need to be able to solve by yourself. Now, you will know one of the answers, but you won't know both of them. Okay, so those were two examples. So we're going to be practicing some of these a little bit right now in the unit, but we're going to practice them mostly at the end of the year because we have nsolve to use on the STAR test, and we're going to come up with another technique to do this a little bit later. But I want you to see how we are going to do it by hand when we're not using the graphing calculators. Okay, so this is the same as solving that. But now, look at this example. X squared minus 5x equals 14. Let's do the same thing. We want to get the x's all on one side by themselves and move everything over. It is an x squared, so it is a parabola, so I'm expecting two answers. All right. When it was just a linear, I'm only expecting that line to cross the x-axis at one place. But here, two answers. Here, I'm expecting two answers. Occasionally, there's no answers because sometimes they don't cross the x-axis, and sometimes there's only one answer because they just touch it at one point with the vertex. So anyway, if you're trying to solve this one, trying to get x by itself, you may be noticing there's a problem here. Can you get these x's combined over here? There's nothing to simplify on this side, but I want to simplify this into a single x thing, right? Is there any way to combine x squared and x? They're not like terms, are they? So that's the problem with trying to solve a quadratic equation when you have both an x squared and an x term. Up here, we only had a single x squared piece and no other x's to the first power. So this was pretty straightforward to do. Just get the x squared on one side by itself and take the square root. This one requires another technique, and that's what we're going to learn today. And this is why we did Unit 6 before we did this unit, the factoring unit, all those polynomials. What we want to do is we want to get everything on one side of the equal sign. We want the x squared, the x, and the number all on one side, so I have that lovely trinomial on one side, and we have 0 on this side. So since we have two pieces already over here, let's get rid of this piece and move it over there. How do you undo adding 14? We subtract 14. If you do it to one side, you do it to the other side. Boom. Of course, nothing's left over here except 0 is equal to, and I'm just going to rewrite this, x squared, oops, my paper's moving, x squared minus 5x minus 14. There we go. So one of the techniques, and there's like 3 different techniques to solving quadratic equations, and one that we're going to practice today is doing it by factoring. Notice I had the x squared, the x, and the number all over here. This is your standard form, right? We moved everything to this side, and we just left 0 over here. This side is a lovely trinomial. Hopefully, it's factorable. Okay, so this technique only works if it's factorable, and you don't know if it is until you try. So let's go make it into a binomial times a binomial. I look for a GCF, but there's not one because there's a 1 in front of this, and nothing goes evenly into 1 except 1. So the goal then is to factor this. X times x will give me my x squared. And some number times another number equals 14. So let's make a list. 1 times 14 and 2 times 7. And I think there's only 2 that give me 14. So now, which one's going to give me a 5? Well, actually, both of them might give you a 5. If you add these, I get a 5. If I subtract those, I get a 5. So I'm going to have to check them both. So I'm going to try the 1 and 4 first. If I want a negative 5, that means they both need to be negative. So if I multiply negative, if I add them together, I get negative 5. If I multiply negative 1 times negative 4, oh, is that the right number? Oh, I want 14. Sorry, that's just 14. 1 times 14. I know you're telling me, Miss Harris, you're right. You wrote it down on 1 times 14. Okay, so it's 1 times 14. Obviously, 1 times 14 won't give me a 5. So that one's off. 2 and 7 will give me the 5. I want the 7 to be negative, and I want the 2 to be positive. If I can write that. Okay, so if I add these together, I get a negative 5. If I multiply them, I get negative 14. Both those things have to be true. So it's plus 2 and minus 7. There we go. Okay, why we factor this side is because if this times this equals 0, that means one of the factors must be 0, because 0 times anything is 0. So if this thing equals 0, then 0 times whatever this is 0. If this one's not 0, then and this one is, then 0 times anything is 0. So that's why they set this whole side equal to 0. You move everything to one side and leave it equal to 0, and then factor it. So then you can come back and say either this is 0 or that is 0, and I'm going to get two different problems here with two different answers. So this is now x plus 2 equals 0, or, let me write this down here real quick, or, I'll come back, x minus 7 equals 0. So now we break it into two problems. Either this is equal to 0 or this is equal to 0. So I literally write it down, x plus 2 equals 0, or x minus 7 equals 0. There's my x minus 7 equals 0. Here's my x plus 2 equals 0. So I broke it into two problems because one of these has to be equal to 0. So how do we solve for x here? We subtract 2 on both sides. And of course, when I rewrite it, oops, the 2's cancel out over here, and x is equal to a negative 2. Sorry, I can't hold the paper and do this. And that makes sense because negative 2 plus 2 is 0, so x is a negative 2. So that's where it's crossing the x-axis, is at negative 2. Or x minus 7 equals 0. How do we undo subtraction? We add 7. If I do it to one side, I do it to the other side. So 7's cancel out, and of course x equals 7. So if you were to go graph this parabola, it crossed at negative 2 and 7. So those are the two solutions. They're my two x-intercepts. So one way to solve quadratic equations is to move everything to one side, set it equal to 0, try to factor the trinomial, and if it's factorable, then I know I can find the two answers of what x can be. So in the original problem, I could substitute in negative 2 here, and this side will equal 14. I could also substitute in a positive 7 here, and here, and do the math, and it will also equal 14. So there's two different numbers that x can be to get you the right answer. All right, so that's what we're doing today, is solving by factoring. Now, the warm-up is those lovely vocab words, because we don't want to forget those vocab words. So here we go. Here are your vocab words. The linear ones, slope and rate. If you go up and over, you're counting the steepness of the line. Slope and rate. Rate is how it's referred to in a word problem. The where it crosses the x-axis is your x-intercept, 0 solution. Again, a solution, except we use nsolve instead of graphing it. Where it crosses the y-axis is your y-intercept, also the starting amount in a word problem. In our parabola, the tipping point where it changes direction is the vertex. And after it's a vertex, it's either a maximum or a minimum. If it's a high point, it's a maximum. If it's a low point, if it had looked like this, it would still be a vertex, but it would also be a minimum. X-intercept and start, same thing. Where it crosses the y-axis, I'm sorry, I said x-intercept, it's a y-intercept. Y-intercept, where it crosses the y-axis, also starting amount. Where it crosses the x-axis, there's usually two of them. X-intercept, 0 solution. And of course, the imaginary line down the middle is your axis of symmetry. We want the equation of that vertical line, so it starts with x equals a number. Okay, so let's go do these problems and see how we're doing. All right, on the first one here, we want to solve by factoring. So the goal is to get equal, the 0 on one side all by itself. And this one already has 0 on one side by itself. I got the x squared, the x, and the number. So all we got to do is factor this side. Now, if they're not factorable, there's another technique to use, but you don't know until you try factoring them if they're going to work or not. So, of course, we're going to have an x and an x. And then we need to think about what times what equals 14. Now, this is one we just did in the little one a second ago. So this winds up being a plus 2 and a minus 5. Now, once you have it factored, because these two things multiply together equal that, either this equals 0 or that equals 0, because if I multiply them together, one of them has to be 0 for me to get that, because 0 times anything is 0. There's a fancy name for that property, but we can just know that if I multiply two things together and it equals 0, then one of those things has to equal 0. So either this equals 0, and you don't have to put it in parentheses anymore, or x minus 5. Oh, did I write 5 there? That needs to be a 7. See, I can't write and talk at the same time. That was x minus 7, or x minus 7 equals 0. There we go, because 2 times 7 is 14. All right, so we're going to subtract 2 on this side, subtract 2 on that side. We have two different problems to solve here. X is equal to negative 2. Or in this one, how do you get x by itself? You add 7, and of course, x equals 7. All right, so two answers that x could have been in that original problem. Let's look at number 2. Again, we want to solve this quadratic equation because it's x squared and it has an x with it. So I can't just get x squared by itself because I've still got this other piece that I got to get rid of. So the technique is get everything on one side so you can see the trinomial is in standard form and 0 over here by itself. Then what you do is you factor the left-hand side. You try to factor it. Hopefully it's factorable. If it's not, then there's a different technique we're going to learn tomorrow. So this is x and x, and something times something equals 4, so we have a choice of 1 times 4 or 2 times 2. What's going to give me a 4? The 2 and the 2. So I need a negative 2 and a negative 2, because negative 2 plus negative 2 equals negative 4. And if I multiply negative 2 times negative 2, I get positive 4. So minus 2 minus 2. That means either x minus 2 equals 0, because either this thing equals 0, or the other x minus 2 equals 0. Now, since these are identical, we're only going to get one answer this time, which means the vertex was just touching the x-axis. If I add 2 and add 2, x equals 2. If you want to continue this through, plus 2, x equals 2. So in both cases, x equals 2. So there's just one answer. This would have been one where the parabola was just touching the x-axis right there at positive 2. So there's only one solution on that one. All right, let's go to this next one. 3. Again, here's my quadratic, and it's got x squared and an x. So when I solve this by factoring, I want to get everything on one side. So I don't have 0 over here, so I want to get rid of this number. So to get rid of a positive 2, we subtract 2. If you do it to one side, you do it to the other side. And then we're going to rewrite this equation. That leaves me with 0 on this side is equal to x squared plus 2x. And negative 1 and negative 2 is negative 3. There we go. And then I'm hoping, since this is now in standard form over here with 0 on one side, that this is factorable into a binomial times a binomial. And if this times this equals 0, then either this thing equals 0 or that must equal 0, because 0 times anything is 0. So this is going to be x, and two numbers multiplied together have to equal 3, and the only choice is 1 times 3. And to get a positive 2, I want the 3 to be a positive and the 1 to be a negative. And if I add negative 1 and 3, I get positive 2. If I multiply these two numbers together, I get negative 3, so that does work. It is factorable. Occasionally, you'll get one that's not factorable, and then you cannot use this technique. So either x minus 1 equals 0, or x plus 3 equals 0. It's a kind of cool little technique, isn't it? So add 1 to both sides. What does x equal? X equals 1. Or if you subtract 3 on both sides, x equals a negative 3. So if you were to graph this parabola, it crossed at positive 1 and negative 3. So that's the two answers that x could have been. You could plug in 1 and 1 here in the x's and do it, and you would equal 2, or you could plug in a negative 3 and negative 3 and go do the math, and it also equals 2. All right, number 4. Again, the goal is to solve this quadratic equation by moving everything to one side and leaving 0 on the other side. Now, since the x squared and x are already over here, I'm just going to move them to the right side. Doesn't matter which side you want to move them to, as long as they're all on one side, and 0 is left on the other side. So this is 0 over here is equal to 4x squared plus 8x, and I always put it in descending order, the x squared, the x, and then the number. So hopefully this thing is factorable. So, but there's a 4 in front of this. I'm looking for a GCF, and nothing goes evenly into 7, 8, and 4. So I'm thinking I need to do the slide and divide. So this is going to be x squared plus 8x plus 28. So now I want factors of 28. 1 times 28, 2 times 14. 3 won't go evenly, 4 times 7. 5 won't go evenly, 6 won't go evenly, and 7's already been used. Okay, so this is all equal to 0. So now I'm going to factor this, and it's x and x. And I need it to be an 8 in the middle. 1 and 28 won't give me that. 2 and 14 won't give me an 8. I'm thinking this one may not be factorable. 4 and 7 won't give me an 8 either, will it? It will not. So this one has no solutions. or at least it's not factorable, right? So this is one that we can't do this way because it is not factorable. Now, there's probably, it may truly still pass cross the x-axis at two places. It's just not crossing at nice, pretty whole numbers, because this factoring technique only works when it's crossing at nice, pretty whole numbers, which is why it's factorable. But you know, sometimes we got those really ugly numbers like 0.414 and 0.312 or something like that. So if they're not crossing at nice, pretty whole numbers, this factoring technique won't work. So even though we don't have any, it's not factorable right now, it could possibly be factorable, and we're going to learn that technique tomorrow. But at least for right now, we would know that we can't use this technique. We would have to try something else just to check to see if it truly is not crossing the x-axis, or if it's just crossing at really ugly numbers that are not showing up here. Okay, so we're just going to leave those hanging for now if they're not factorable. I really should just write not factorable on that one. Number 5, same thing here. We want to get x by itself. Oh, look, there's only an x squared term, not an x squared and an x to the first power. So I may be able to just solve this one by getting x by itself. So how do we undo multiplying by 5? You're right, we could just divide by 5. And x squared equals, and this winds up being, what's 80 divided by 5? Is that, oh, it's 16, isn't it? It is 16. That's nice. So how do we undo squaring something? You take the square root. You take it to one side, you must do it to the other side. So this equals x, because they undo each other. And square root of 16 is 4, but it's a plus or a minus 4. Because over here, x could have been a positive 4. 4 times 4 is 16, or it could have been a negative 4 times negative 4 equals 16. Now, how would we do this one if you didn't recognize that you could have done it this way? We could also still do the factoring version. So let me do the factoring version here real quick. We would still get everything to one side. So this is 5x squared. And subtract 80 on both sides, minus 80 equals 0. So now we have that over here. Remember, the middle term over here was a 0x squared. I probably should have written that in there. But the middle term is a 0x squared. But we would look for a greatest common factor. Will something go evenly into 5 and 80? Yes, 5 will. So we could pull that 5 out. And this is going to be 1x squared, which is what I want. 5 times x squared equals 5x squared. 5 times, now I'm going to put the 0, 1 in here. Plus a 0x. 5 times 0x is still 0x in the middle of that. And 5 times what is 80? It's a minus 16 equals 0. All right. So if you did not recognize up here that we could have done it this way, you could still put everything over here on this side and have the 0 and factor this thing. So here's my GCF still sitting out front, and then we're going to factor this into 2 binomials equals 0. And of course we have x and x. And what times what equals 16? It has to be the same number so that they can add up to 0. That's a 4 and a 4. Now, I want one to be positive and one to be negative, so that when I add them together, they equal 0. But when I multiply them, they should equal negative 16. So that means either 5 equals 0, because I've got 3 things being multiplied together here to equal 0. So one of these 3 things has to equal 0. Now, we can set 5 equals to 0, or x plus 4 equals 0, or x minus 4 equals 0. There we go. Now, is 5 equal to x? Obviously not. So the 5 cannot be my 0 because it's a whole number, right? So that one won't be my 0, but either x plus 4 is 0 or x minus 4 equals 0. So negative 4 plus 4 gives me a 0. So in this one, x equals negative 4. You can subtract 4 on both sides. If I add 4 to both sides on this one, x equals positive 4. And is that what we got up here, positive and negative 4? Positive and negative 4. So either way you did that one, you got the same thing. So we're practicing these. We'll do this a lot after the STAR test. I'm going to show you some other ways to do it for the STAR test, but this is the technique you use when you don't have a graphing calculator for all your future tests and your future classes. So we want to at least show you this so that when we go back and do it at the end of the year after the STAR test, it won't be so foreign to you. So we're going to practice a little bit now, because some of you may want to do this on the STAR test and then check it with the calculator. So again, solving a quadratic equation, the goal is to get x squared on one side all by itself. Now, or the x squared, the x and the number all on one side and have 0 on the other side. So then we factor this side. So if we want to do the factoring technique, and yes, you could have just solved for x squared and taken the square root of both sides. That's a faster way to do these, but I'm going to show you the factoring one just because we're kind of focusing on that today. So if I write this into a trinomial, it's x squared plus 0x minus 36 equals 0. And of course, if we're going to factor this, equals 0, x times x. And what number times itself equals 36? It's a 6 and a 6. And of course, to be a 0, that means one's going to be positive, one's going to be negative. So if I add positive 6 and negative 6, I get 0. If I multiply them together, I get negative 36. So either x plus 6 equals 0 or x minus 6 equals 0. And then if you subtract 6 on both sides, x equals a negative 6. If I add 6 to both sides, x equals a positive 6. And if you had done this up here, the other way around doing it was just solving for x squared. So if I added 36 on both sides, that means x squared equals a positive 36. And how do you undo squaring? You take the square root. X is equal to both a positive and negative 6, because the square root of 6 is both positive 6 and negative 6. All right, so there's the first page. Stay tuned for the next video, and I will give you the second page.